Our next team is from the Florida International University, EACC Engineering, presenting on the Carretera Central Restoration Project.
First of all, let me start by thanking each and every one of you for being here this morning. I know it's early on a Saturday and everybody wants to be doing something else, but I appreciate you coming here. First, let me start by introducing the team. We have Edna Pertouche. She's an FIU undergrad. She's an intern at David Plummer and Associates, and she's the current president of the CAC Student Chapter. Christopher Soto is an undergrad also at FIU. He's currently an inspector with AMP. And this is Adrian Alfonso. He's also an engineer with AMP and a graduate student at FIU. My name's Carlos Camacho. I'm a graduate student at FIU, and I'm also an engineer with AMP. So in order to create this project for you, we thought about the two most important questions. One of them being set up in the premise that was given to us, in terms of the flyer. And first we had to imagine what the regime would look like once, day one after it changes hands. And after that, we'd have to decide, based on that, what can we as engineers do to help rebuild the island. And I'm not sure if you remember, but when some of you who were civil engineers were in school, one of the biggest selling points was that we need infrastructure. That infrastructure is the most important economic growth model that we can implement simply because of the ease of travel, the ease of bringing goods and people in and out of the country. And so we thought as the group that would be the first thing that we would need to do once the regime changes. So our goal in this presentation, is to present to you two different aspects. One is to illustrate the possibility of performing a roadway reconstruction project in the middle of chaos, which even in the best of circumstances, when the regime changes over, it's going to be chaotic. And number two is we would like to help stimulate the economy by we're going to present to you a 1 mile stretch of road, and we hope that we can use it in the future as sort of an example and say, look, you can do it, this can be done, and this can be repeated over and over and over again. Now, one last thing before I hand it over to my colleagues is you're going to hear sometimes references to FDOT and DERM, and that's not because we forgot that we're not in Florida, we're in Cuba, but it's because the FDOT and DERM and the local authorities have a set system in place that we can use to take over there until they get their own systems in order. And now, Enda.
Here's our outline for our presentation, and these are the topics we're going to be talking about. I'm going to give you a little introduction. After decades of neglect, to say Cuba's infrastructure is in need of a repair is an understatement. In order to participate in the benefits of a free enterprise system, Cuba's first step will be the reconstruction of infrastructure up to and beyond the modern standards. This essential engineering work will facilitate the growth of the domestic and international business, and this project will assist a new Cuba in restoring a section of Avenida 51 from Calle 222 to Avenida 202 in La Habana, Cuba. This right here is the location map of the corridor we're going to be analyzing, and you can see our boundaries from Calle 222 to Avenida 202, and we've created this for you. This is a little background on Carretera Central. It's a highway that gives east and west access throughout the island of Cuba. The construction began in 1927, and it was completed in 1931, and it cost about $107,000 per mile to complete this project. In the 1950s, Carretera Central was one of the most efficient highway systems in Latin America, but since the late 1950s, there hasn't been much investment made into the transportation system, which has caused the roads and the highway system to deteriorate. And this has affected the economic growth for Cuba. And right here, we've shown a map of Carretera Central. Okay, for the roadway characteristics, Avenida 51 is a major arterial. It runs from Pinar del Rio to Guantánamo. But within the project vicinity, Avenida 51 is going to be a 4-lane, 2-way undivided roadway. It's going to have 11-foot travel lanes, 10-foot shoulders, sidewalks, and the posted speed limit will be 40 miles per hour. And we've shown this exhibit here for you, which is the proposed lane configuration for our corridor. And the two intersections, which are Calle 222 and Avenida 202, are local roadways. Calle 222 is going to be a 2-lane, 2-way undivided roadway. And Avenida 202 will be on the north side of Avenida 51. Is going to be a 4-lane, 2-way undivided roadway. And on the south section will be a 2-lane, 2-way undivided roadway. In order to perform the roadway capacity, we're going to use the Synchro software for the intersections and the corridor, and this will help us establish the existing level of service and the future level of service of this to make sure it will run smoothly. In order to get this information, we're going to have to do turning movement counts and segment volume counts during the AM and PM peak periods, and this will help establish the existing level of service. And right here we provided, is from the Florida Department of Transportation, the quality level of service for a 2-lane undivided with left turn lanes. And these are the peak direction volumes for each level of service. For the intersection analysis, what we're going to accomplish is a safer roadway for drivers and pedestrians, since there's a high percentages of pedestrians on this roadway. Also, for this intersection, the signage position and size is very important because you do have drivers with vision issues and slow reaction time. And by fixing this, it will help prevent high rates of crashes, pedestrian fatalities, and also by having intersections, it will control the right-of-way, and this will reduce any traffic delays, accidents, producing conflicts to the existing and future traffic. And in order to achieve this, the intersection capacity will have to be established. And if we do have to implement new intersections, a traffic signal warrant will be recommended to make sure that it is needed at that section and not create extra chaos in the traffic. And also signal timing implementations will be needed. I had to press play. This is a simulation we've created for you today from Synchro. So you can see the corridor. We've put some traffic in it. And you can also see the two intersections, and it's gonna zoom in and it's gonna show the traffic flow on the corridor.
As far as signalization is concerned, we plan on placing a mast arm at the intersection of Calle 222 and Avenida 51, as well as mast arms at the intersection of Avenida 202 and Avenida 51.
Over here, as you can see on the side streets, we utilize stop signs along the side streets because if not, it'll create too much stopping and going. And then over here on this side of the project, later I'm going to show you a detour plan that will utilize these side streets around the back for use of detour planning for nightly shifts to be able to phase the traffic back and forth.
All right, so it takes several disciplines to get a project like this done. One of these disciplines is going to be the geotechnical engineering aspect. We approximate there will be no more than 3 core borings needed for this project. Mainly, we take a core boring where we expect miscellaneous structures to be placed, so at least 1 per intersection. The borings will be done using the standard penetration test. This will allow us to get N values that will later lead to other soil properties, which I'll go over later on to basically design the roadway and design the foundation for the structures. In our previous research, we have seen that the predominant material in this area is the red limestone. That being said, we are not going to blindly go by this. When we take the geotechnical core borings, we plan on taking the material to the lab to analyze and specifically find out if the research is backed and find out the true strength of the material in the area. Here's a chart of the information we expect to be obtaining from the geotechnical report. As you can see on the left column, we're going to show the elevations that show the different layers of the soil. These elevations basically signify that the soil has changed from different elevation sectors to the next. We here will show the total unit weight of the soils. We can also obtain the water levels, and we also obtain the soil friction angles, which basically shows us how strong the soil is to provide a good design. Why do we need this information? To design the roadway and other structures. The pavement design is important for the longevity of the roadway and for for the roadway not to have any potholes and things like that. The pavement design will include a FC 9.5, which is a one thick layer friction course at the top, an SP 12.5 structural course. We expect about 2.5 inches for this layer, and a base course of about a 2 foot depth. Now, another reason that we need these geotechnical is for the foundation of the mast arms. Here we have a typical core boring. The typical drill shaft that will show us the depth of about basically 10 feet. We don't expect anything greater than a 3 foot diameter to be used, and this is to optimize the structural design. This is a typical mast arm. This is pretty much what the project we're trying to get to implement a better safety in the roads. That way we have the lights above and everyone can see what's going on. There's also been a safety study to add backplates around the lights for better vision, and the budget of the project will ultimately determine if we implement this. The design of the mast arms, may include a luminaire, as I've shown in the diagram. This is for lighting the roadway and at night, and better safety, as well as another safety issue is providing pedestrian walkways and bicycle paths. And I'm gonna bring in Carlos for another discipline.
Thank you.
Please.
So due to the lack of information from the island, the design of the drainage would have to be somewhat generalized. Once we get on the ground, we'll have to investigate each and every single catch basin, manhole, pipe, to get an idea of what the design is like. Obviously, we can expect lack of damage due to lack of maintenance and just because the system is extremely old. So we will take that information back to the office, run hydraulic models, and see if the system is adequate, if it needs to be expanded, if it needs to be refurbished, if we can leave it, if we can clean it out. Once we have that, so then from there we have two options. If the design is adequate, we can go ahead and run another investigation and assessment, as if you will, to decide what we're going to keep, what we're going to throw out. And then we go ahead and proceed with construction. If for some reason we decide we have a little bit more money and then we decide to redo the whole system, then we'll have to go through the, in my opinion, we should go through the FDOT process in order to design a new system so that we can leave them with something much better than they have now. And the one thing that I would like to impart is that the best thing to do for the Cuban people in a new regime would be to give them a simple system that they can maintain and repair in the future, and it doesn't cause them too much of a burden, so that they can continue to do this over and over again throughout the island. Christopher.
Roadway construction. EACC Engineering has constructed a simple but comprehensive management plan to go ahead and process the project on a time and quality basis. Go ahead, next slide. Over here we have constructed a few bullet points to describe what is the critical aspects of construction management, strict adherence with environmental permit requirements, but most importantly, utility coordination. The utility coordination is what makes or break a project based on the claims that we have during projects. So we will go ahead and do subsurface engineering to locate the utilities along the project. The phases of work will have significant importance on maintenance of traffic and public outreach for the safety of the public and the safety of the workers on the project, because there are a lot of fatalities during construction work zones, sadly, but if we continue a safe maintenance of traffic and public outreach, we can go ahead with that. And then phases 1 and 2 of Avenida 51, we're going to utilize a concrete barrier system with an attenuator at the incoming traffic side. This is a detour plan for the nightly shifts. You have the work zone along this area, or we'll detour them through the side streets of the project. Additional items of work, we got to concentrate on the final friction course, the thermoplastic, 30 days post that, installing permanent signs left to be done, and reconfiguring all the lighting on the mast arms to the permanent construction. On the budget aspect of the project, we have to go for the $4 million budget that we did based on the construction quantities of by the historical data for the of FDOT. That's how we came up with the $4 million value, and we're gonna go with the highway trust fund to based on user-related taxes and fees to help maintain the road and to promote economic growth. And this is our conclusion. I know we're out of time. I'm sorry, there's a lot to go over. Thank you. You guys have questions?